Hello, my name is John Schultz, and I'm with the Compass Technology Group. And today I'm going to walk you through the operation of the dielectric epsilometer device measuring an unknown sample. We have the software open, and we've already connected to our device. So the first thing we're going to do is fill out the description, which in this case, we're just going to type demo. Next, we input a file name root. The file name root is what goes at the beginning of each file. And I'm just going to say DD for now. There's a sequence number, which allows us to take multiple measurements and not accidentally overwrite them. And now we're going to calibrate by inserting our Teflon specimen into the device. So the Teflon goes in between the electrodes. There's a top knob, which we very gently tighten down until it's just snug. And then there's this loose knob here, which we press and tighten. And this is a torque limiting knob that allows us to give consistent torque or pressure on our specimen. Once we've done that, we then press the calibrate measure button. The device scans from 3 megahertz up to 6 gigahertz. You can see the phase data is displayed on the screen, and we're calibrated. Now we can take this out by undoing the knob and sliding our sample out. Next, we're going to measure our unknown specimen. So we go to the measure box. We input the specimen thickness, which in this case is already input. It's 0.8 millimeters. We insert our unknown specimen, same place that we put the calibration material. We do the same thing. We gently tighten the top knob, and then we use the loose torque limiting knob to give our final tightness, and then we press measure. The software is scanning the analyzer across all the frequencies, and then it's doing a database lookup to determine the dielectric properties based on the measured properties. And then what's then displayed on the screen is the dielectric permittivity as a function of frequency. And there's 2 lines here. The solid line is the real permittivity, the dielectric constant. The dashed line is the imaginary part, or the loss. You can also, over in the measure box, there's a checkbox to display imaginary epsilon as tan delta. When you click that, it automatically changes the imaginary part to tan delta instead of imaginary. And that's all there is.